All right, camera's rolling here. Back at it. Hopefully, you guys are dominating problems and being good problem solvers and really applying those two moles and reactions chapters. What we need to kind of add on here, or one of our last little sprinkles, is when percent yield comes into play. And again, you'll see you have 2 days for these problems just because it's a whole nother level of thinking. But what it really boils down to can be summed up in a real life example. So when we do labs, which I know isn't happening this quarter, rarely does lab ever go perfectly. Very, very similar to the real world. So just the other day, I may or may not have used Joanna Gaines' cookbook to make some chocolate chip cookies, and it was supposed to make 24 cookies, the recipe amount was. I must have messed up somewhere along the way because it actually only made 21 cookies. I think you guys can all probably attest to a real life example of this. If I really apply this to a chemistry thing, that's what's going to happen a lot. I mean, we're supposed to make 400 milliliters of acetylsalicylic acid, and we get done and we only made 360. That's where percent yield comes into play. So if we stick with this cookie example, what ends up happening is that if we took what we actually made divided by what we were supposed to make, I'd take 21 divided by 24. What we end up calling this bottom number, just new terminology, is called the theoretical yield. This is called the actual yield, and this is called the theoretical yield. Theoretically, I was supposed to make 24 cookies. If I go and solve that, it comes out to 0.875, which we don't really care about as a fraction. So what you'll do with your percent yields is take them times 100 to be a percentage that means something. And what this means is that we made 87.5% of what we were supposed to make. And this is going to happen in lab. There's going to be some reactions that can't be perfect no matter what because of side reactions. Maybe some gases are released, but this is a way that we'll sometimes evaluate how thorough we're being in lab. And ideally, if we're going to try to make 3 grams of copper, we want to be as close as possible to 3 grams of copper, but percent yield is how we express how much we actually collected. So let's look at 2 examples together here. This will be your equation. It'll be actual over theoretical. That's the way that I teach it, and you'll see different words. Some people use different terminology. They say observed. How much did you observe that it make? But I always go A over T, and then it's times 100. So that actual, in the problems, it'll say that that's how much you make. A chemist recovered this much. You isolate 5 grams of copper. And then just don't forget, the theoretical is what you do on paper. That's in the perfect world, no mistakes. The answer that you get with your pretty little box around it is the theoretical yield. And that's how you'll calculate the percent yield of a problem. So the first one here, I just used an old problem that we actually just did. So most of the time, you're going to find the percent yield at the end of the problem, and you'll see what I mean here. So this was a practice problem we did the other day. I actually just recorded the video a little bit ago, but we said in this problem that we were supposed to start with 26.3 grams of copper. And I really, this one probably isn't going to be a perfect example, but you guys will get the hang of it. But 26.3 grams was how much copper. Let's even say that it was the other way around and I was making copper, because that's probably a better example. But this is how much I, in a perfect world, should have made if I did everything right. So what the problem would actually be is, let's suppose you actually only ended up with 21.5 grams of copper. So I kind of realize now that I'm in this video, usually it'd be a product. I kind of messed up on this one, but we can get the hang of the percent yield. So we were supposed to make 26.3 grams of copper, and we actually only made 21.5 grams. So I want to know what your percent yield would be. We'll set up our basic equation. Percent yield will always be the actual amount we make versus how much we theoretically should make, and we'll take it times 100. So if I go plug in my values, I actually only recovered 21.5 grams of copper. According to all my perfect work over here, I was supposed to make, or theoretically make, 26.3 grams of copper. I take that times 100, which would mean I recovered 81.7% of what I was supposed to. So we'd report that as an 81.7% yield in this experiment. Let's do one more together here. That one kind of shows you the idea of it though. So this will be a full-blown example problem. So again, get a blank piece of paper and follow along with me here. You mix 10 grams of potassium with excess chlorine gas. So there's our reaction right away. If you actually recover 15 grams of potassium chloride, this would be what you did in lab. What is your percent yield? So now you guys can see this all comes full circle as a stoichiometry problem. We start with our blank reaction, and I know this isn't going to be pretty on my PowerPoint here, but solid potassium is K. We know chlorine gas is diatomic. And then These two things are a synthesis reaction, so we crisscross. Bodie, no! And then we gotta balance it. So I go and balance it. I need 2 potassiums. I have 1 chlorine and everything's balanced. Oh, no! So then I go set up my brackets. I see that I have 10 grams to start with. I'm just being a problem solver here. I draw my bracket because I want to get to KCl and see how much I was supposed to make. So I go set up. I know I need my mole ratio. So I have 10 grams of potassium. In order to switch and get to KCl, I need my mole ratio. So I got to get to moles. So I cancel out grams of potassium with the molar mass. So now I'm in moles of potassium. I can now use my mole ratio, which I see is 2 to 2. I know that that step seems frivolous. Just make sure if you're going to cancel it, don't forget to cancel both of them since it's a 1-to-1 ratio. If I stopped right now, I'd be in moles of KCl, but I can see up here that I have grams of potassium chloride. So then I got to go one more step and get from moles of KCl. I calculate the molar mass, and if I cancel everything, grams of potassium cancels grams of potassium, moles of potassium cancels moles of potassium, moles of KCl cancels moles of KCl, and now what I'm going to get here is that I theoretically, in a perfect world, should have made 19.1 grams. So now I got to think about what the problem asked, and it asked me to find my percent yield. So I go set up, actual divided by theoretical. I'm going to take it times 100 eventually, but I actually recovered 15 grams of KCl. I theoretically, according to my perfect world work, was supposed to make 19.1 grams. So I divide those, take it times 100, which would mean I recover 78.5% of what I was supposed to, and my percent yield would be 78.5%. Usually you'll do it at the end, but it's just your basic stoic problems. Rock and roll, draw your brackets, be good problem solvers. Good luck.